Good morning, everyone. I missed all of you. I hope you are all doing well, you and your families, and that you did well on yesterday's test. As soon as I have the tests graded, I will get them all back to you. So let's start with the do now for today. The do now says, how many triangles are possible and show all work. So I am giving you triangle ABC and giving you the angle B is 40 degrees, A is 12, B is 6. I'm hoping from looking at the givens that you are saying to yourself, okay, I've got angle B, I've got side B, here's side A, I can find angle A. Because remember, that's what the law of sines is. The law of sines allows you to find angles for sides as long as you have two angles with the corresponding opposite sides or two sides and the corresponding opposite angles. So go ahead and find angle A. Then I want you to analyze angle A once you find the degree measure. And let's see if you could tell me why there are no triangles that are possible. If you're able to do that, we're good. If you're not, then please come on to Zoom and then we'll talk about what the answer is or how you would get the answer. So now let's go ahead and go on to page 2. The basically the most important part of the lesson. Okay, so here I've got triangle RST, and you were asked to tell whether or not you can use the law of sines. So I have side S 10, side T 17, angle R is 105 degrees, and you are told to find the measure of side R. So what can I use the law of sines? Well, here's what the law of sines says. Think back to not yesterday, but the day before. That R over the sine of angle R equals side S over the sine of S, and then side T over the sine of T. Again, I need two sides and two angles. Here, I only have but one angle, and there's no way of knowing what angle S is, so I can't use side T. I can't use side S, the 10. I don't know what angle T is, so I can't use side T. And even though 180 minus 105 is 75, I can't divide by 2 because I don't know that they're congruent. So the answer should be no, because you need info about two angles in the corresponding opposite sides to use the law of sines. So I want that to be clear, because if you're ever given a problem where you're deciding which one to use, you need to know when I can use the law of sines and when I have to use the law of cosines. So let's look at what to do with the law of cosines. So here I have the exact same problem. But now let's talk about the law of cosines and what that says. So there are three different ways I can write the law of cosines. I am here using ABC, but I could use RST, I could use WXY. It doesn't matter what the letters are that I'm using, as long they just stand for basically just sides and angles. So in this version, I have c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. I also have a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. And then the last variation is b squared equals a squared plus c squared minus 2ac cosine of b. Make a note, please, that the same letter starts and ends the equation. That's going to help when we do the setup in a little bit. So what I'm going to do is actually end this slide, because apparently when I make it too long, it doesn't post. And then on slide 2 is where we're going to look at how to do the problem. So let me go ahead and just name this A21 Law of Cosines. And go ahead and just stop this recording now and go on to slide 2.